Hey everyone, and welcome. So, we've all been there, right? You ask an AI a question, and bam, you get a perfect instant answer. It honestly feels like magic, like it just knows things. But have you ever stopped to wonder how it all actually works under the hood? Well, today, we're going to pull back that curtain and see what's really going on. So let's start with a really simple question, something anyone could answer. Imagine we type this into our favorite AI. It's a basic fact about the world.
And just like that, almost instantly, we get the correct answer. Simple, clean, perfect. The AI didn't even break a sweat.
And this is the big question, isn't it? I mean, it doesn't have eyes. It's never seen a dog. So where does this knowledge actually come from? Well, it's not magic. And trust me, the real answer is way more interesting. Okay, so the very first thing we need to get is that an AI doesn't read a sentence the way we do. Before it can even think about an answer, it has to chop our question up into little manageable pieces. And this process has a name. It's called tokenization. So what on earth is a token? Well, think of it like this. If a sentence is a finished meal, then tokens are all the individual ingredients, all chopped up and ready for the recipe. It's the only way the machine can actually process what we're asking. And what's really cool is, this works no matter what language you're using. To see what I mean, let's look at the same exact question, but this time in Japanese. See? To the AI, this isn't a flowing sentence. It's a list. Token 1 is dog. Token 3 is legs. Token 5 is number, and so on. This is its starting point.
All right, so the AI has its list of ingredients, its tokens. What now? This is where you have to kind of shift your thinking. These large language models, or LLMs, they aren't giant encyclopedias. They're incredibly powerful prediction engines. Their entire job is to just play a game of what comes next.
And this is the absolute heart of it. The AI is not thinking about an answer. It's doing math. It is calculating based on the trillions of words it's been trained on what the single most likely word or token should be to start the answer. And this chart shows you exactly what that calculation looks like in action. After seeing the tokens for dog, legs, and number, the model runs the odds. And it sees a massive probability for the token 4, a tiny one for the Japanese character for 4, and an even tinier one for 2. Yeah, 92% for the AI, that's not even a choice. You know, it's a statistical slam dunk. Based on countless examples it's seen before, 4 is the overwhelmingly likely next token. So that's the one it picks. And here's the real secret sauce. Once it's chosen that first token, the whole process just repeats itself. It's not thinking of a full sentence. It's just laying down one brick at a time, building the answer token by token. So, brick number 1 is down, the token for 4. Now this token becomes part of the new puzzle. The AI's new question is, okay, given the original question and the token 4, what is the most probable next token? So it runs the numbers again. And this time, it predicts the token han, which is a Japanese counterword with an 85% probability. It's just the most natural word to follow the number 4 in this context. So boom, it adds it to the chain. And again. The context is now for han. The model predicts desu, which is basically like saying is or are with a whopping 91% probability. It's the grammatically correct choice, so it gets locked in. Finally, the context is a nearly complete sentence. What's the most likely token to come now? A period, of course. The model calculates this with 99% certainty. And just like that, the answer is complete. And this is what's so wild. That final sentence, it never existed as a complete thought. It was assembled sequentially, one piece at a time, based purely on what token had the highest probability at each and every step. So let's just zoom out for a second. We've seen this mechanical, step-by-step process. So why does the end result feel so much like genuine understanding? How does it feel so human? Well, it's because the outcome of all that math perfectly mimics a logical, human-like thought process, right? It looks like it identified the dog, looked for the attribute legs, applied its knowledge, and then formed a sentence. But as we've just seen, it's actually following a completely different probabilistic path to get there. So this is the core of it, really. On the one hand, we have the illusion, a machine that thinks and understands and knows. But on the other hand, we have the reality, a powerful prediction engine that is simply and brilliantly playing the odds on a massive scale. And that leaves us with a really fascinating final question. If a system can perfectly replicate the output of thinking just by predicting the next word, what is the real difference between that and actual thought? That's something to ponder. Thanks for joining me for this explainer.